Good afternoon everyone. Welcome back to Sri Chaitanya Academy YouTube channel. Today we are on a new lecture, right? So today we are going to talk about integration. Okay, so this is our second lecture in integration. In the last lecture I gave you a brief about what integration is, right? We also wrote some important formulas for integration. Okay, so today we are going to build on that integration part and see how integration is important for us. Okay, so the two things which are very important are differentiation and integration. Okay, differentiation and integration will remain with you for the whole journey, 2-year journey. Okay, so you cannot afford to like mismatch things. Okay, you have to learn now, because later on what happens, right? Students basically they forget things. Okay, and when they forget things, okay, in physics what happens that they are afraid of this maths part, integration and differentiation. Okay, they know the concept, they know the formula, but eventually when integration and differentiation comes there, right, they are bit of stuck there, and that is why they are not able to score well in physics, correct? So what do I want you to do is understand the concepts of integration, differentiation, and the last topic which we are going to do is vectors. Okay, clear? So let's start without further ado. So let's first revise, okay, on the formulas which we did yesterday. So integration, right? How do you write integration like this, right? Integration of sine x dx is equal to minus cos x, correct? Okay, integration of cos x. Okay, let's start with the basic ones first. Okay, let's start with the basic ones first. So the first formula is integration of constant. Okay, integration of a constant is equal to constant multiplied by x, okay, plus some new constant c dash, okay, some new constant c dash. Second, integration of a power function x power n is given, x power n dx is given as x power. Now what happens, this n we have, right? So we add 1 to the power and divide by n plus 1 plus some constant c. Okay, integration of a linear function. So ax plus b is a linear function which we have, right? So what can I do? I can apply the rules of integration to both of them, no, individually. So what can I have? I will have integration ax dx, okay, ax dx plus integration b into dx. So what do I get here? Here I will have a x square by 2 plus, for this I will have b into x plus some constant c. Okay, now third, let's suppose we have integration a power x. So what is a power x integration? Is a power x upon ln a. Okay, and if I substitute a as e, I will get e power x dx here. So I will get integration e power x as integration e power x. Okay, so this were the basic, and one more reciprocal function, 1 by x dx integration is equal to ln x plus some constant c, okay, plus some constant c we have to write here. Okay, now we also had some trigonometric functions, right? So for the trigonometric functions, okay, what are the formulas for that? Let's write them. Okay, so for trigonometric functions, integration sine x dx is equal to minus cos x, right, plus some constant c. Integration cos x dx is equal to sine x plus c. Okay, now integration, okay, now we have, see, for the basic normal functions, no, for we know that what is the differentiation of tan? What is the differentiation of tan? Tan is sec square x. So the opposite of sec square x. So basically I know that derivative of tan is sec square x. So integration of sec square x dx will give me tan x. Similarly, integration of, right, cosec square x dx will give me minus cot x plus c. Okay, basically we are doing the opposite. See, if we differentiate this, right, if we differentiate this, what is the differentiation of cot x? Cot x is minus cosec square x, right? So the same thing we are getting here. Now, integration of sec x tan x dx is equal to, now I am integrating this. So what is this? This is basically the differentiation of what? Sec x plus c. And finally, differentiation of cosec x into cot x is minus into dx is equals to minus cosec x plus c. Okay, so these are some important formulas for differentiation that you should know. Okay, and see, why I am telling you to remember these formulas. Eventually, see, if you remember these formulas, what will happen, that the way you will learn, okay, the way you understand things will be very easy for you. Okay, it will be very helpful for you, and you will be able to do integration. Correct? If you don't know these formulas, you will not be able to proceed, because you will not, okay, you will not do the derivation every time. Okay, once they are derived, they are derived. Clear? So let's move forward. So let's do some multiplication rules. Okay, so there are rules of integration. So first is multiplication of a function by a constant, right? So let's say if I have a function fx, okay, and that is given as a is a constant, and let's say x. Okay, let's say this is a function. So what did we, so if I want to integrate this function, if I want to integrate fx dx, right, what do I have here? I have integration, okay, ax dx. Correct? When I have something like this, what happens to this constant? This constant will come out of this integration, right? It is the same thing we did in differentiation. What happens to the constant? This constant comes out of the integration. And what do I have here? A into, now integration x dx, see, this is x 2 by 2, x square by 2. Why? Because there is power 1. So what happens to the power rule? Power rule is 1 plus 1 divided by 1 plus 1. That will give me 2. Okay, so this is my final answer which I have. Okay, so what is the rule here? That if we have a constant and I am integrating this function, this constant will come out of the integration. Okay, next. So let's solve this question, right? If I want to solve this question, how can I? Let integration fx dx is equal to integration, now what do I have? Minus 9x dx. Okay, so now what is the constant here? What is the constant here? If you look very nicely, the constant is minus 9. So I can take this minus 9 out of the integration and I will be able to integrate this. And now this is very easy. What is integration of x? Integration of x is x square by 2. Integration of x square by 2. So this is my final answer. Okay, next, differentiation of sum and difference of a function. Okay, so now differentiation of sum and difference of a function. So basically what do we have here? Here we have two functions. Okay, so what are the two functions? Let's say that fx is my function and it is made up of two functions, hx plus gx. It can be plus also and it can be minus also. So my function, my first function is made up of sum or difference of two functions. Okay, what are the two functions? Hx and gx. Now if I want to integrate this function fx, right, so basically I will apply integration to this whole function hx plus minus gx, correct, into dx. Yes or no? So now what does the rule says? The rule tells us that if I have something like this, okay, what can I do? I can apply this integration to both of them individually, right? So what this becomes? This will become integration hx dx plus minus integration. Now what is this? Gx, right? So I can write gx here into dx. Okay, so now what we'll be able to do? I have this first function hx which I can integrate with respect to dx plus minus this gx function which I can integrate with respect to dx. Okay, so let's see this by a simple example. So what do I have here? I have, see how many functions I have. If I look here, I have first function, I have second function, and I have my third function. So let's try to integrate them. Okay, so integration fx dx is equal to integration. Now 6x cube minus 9x plus 4, right, into dx. Why dx? Because I am trying to say that this is my function fx and I want to integrate this with respect to dx, right? Yesterday I told you, what does this mean? How do you read this? To read this, okay, what does this mean? This means, this tells us that I want to integrate. Okay, this tells me that I want to integrate, right? Now, what is this? This is the function which I want to integrate. The function which I want to integrate. Okay, and what is this? With respect to x. Okay, whatever is written here, I will say that I want to integrate this function with respect to x. Okay, clear? So now let's try to solve this question further. Okay, so what do I have here? So what did I tell you? That I will apply integration on each and every part. So what do I have? Integration 6x cube dx, right, minus integration 9x dx plus integration 4 into dx. Correct? Now what is this 6x cube, right? So 6x cube, what can I do? I can take this 6 and put it out of the integration. So what do I have? 6 integration x cube dx, right, minus, now what is this? 9 is a constant, so I can take this 9 and put it out of the integration. So I will have 9 integration x dx plus, now this is 4, so I can take this 4 out of the equation and I will have dx, right? So further, if I want to integrate this, right, what do I have? Integration 6x cube, so 6 is there written as it is, and integration of x cube will be x power 4 upon 4. Why x power 4 upon 4? Because the integration of x power n is x power n plus 1 divided by n plus 1, okay, as we know this, right? This is the formula which I am using here. Okay, so now since I know this formula, okay, I have solved this first part. For the second part, I am writing here is minus 9 x square by 2, okay, and finally it will be 4 into x. Okay, so what do I get? I get 3 by 2 x power 4 minus 9 by 2 x square plus 4x. Okay, so this is my final answer once I am able to solve this. Clear? So I hope this is easy. This is not that difficult. The only thing is you should understand that how I am applying the integration to each and every term of this function. Okay, let's move forward. So I have this question, okay, I will give this question for homework. Okay, you please try to solve this question. Okay, I will give you a hint, right? What is the hint? That you first try to simplify this function. This function which we have, right, I can write as 6 into z power minus 3 by 2, okay, plus 1 by 8 into z power minus 4 minus, I can say, z power minus 10 upon 3. Okay, if I am able to write this function, can I write this function first of all like this? Okay, and once I write this function like this, okay, you try to simplify it. Okay, so okay, Rajat, okay, Rajat, what doubt do you have? Okay, we can move forward. Okay. Okay, then you please write your doubt in the comment section, okay, chat section. I'll try to solve that. Okay, so now, so these are the two rules, right? What are the two rules? That first of all, that if I have my function which is multiplied by a constant, right, I can take this constant and, right, I can move that out of the integration. Second is that if I have two functions, okay, which are as written as a sum or difference, right, I can apply the integration to them individually. Clear? Okay, so let's move forward now. Next, so integration by parts. So for this integration by parts, right, so this is a new technique, right? What is this technique? That in the differentiation part, right, what are the things which we did, right? We did product rule. What was the product rule? That if I have two functions u and v, right, and I want to differentiate them, right, how can I differentiate them, right? So let's suppose, let's revise that first differentiation so that you understand what we are trying to do here. So let's say if I want to differentiate this, right? So if I have u into v, okay, this is for differentiation, right? So let's say if I have two functions u, right, into v, and I want to differentiate this, okay? So if I want to differentiate this, right, so how to differentiate this? So differentiation of u into v is given as, right, is given as, what do I do? First of all, I will first differentiate the first function. So I differentiate the first function and I keep the second function as it is, correct? Plus, now second thing is what I'll do, I will keep the first function as it is and I will differentiate my second function. Okay, so this was the product rule for differentiation. Okay, then we did the division rule, right? Then we did the division rule. And what was the division rule? If you remember that u by v, right? If I have a function written as u by v, and if I want to differentiate this, what did I do? First of all, I told you, no, that you keep the numerator as it is. First of all, you differentiate the numerator, you differentiate the numerator and you keep the denominator as it is minus. Then you keep the numerator as it is and you differentiate the denominator, right? And finally you write the denominator square. Okay, so and finally also we did the chain rule. Okay, what was the chain rule? Okay, so chain rule was we start differentiating from the outer function and we go on differentiating till we reach the innermost function. Okay, so for this, if you want to revise this, okay, you can check the playlist. Okay, all the videos you will get there. We have done around 12 videos now, correct? And I have covered all the basics, okay, whatever maths you need for physics. So please go check the playlist if you feel lost in. Okay, so we'll move on to integration. So basically we are doing integration, and in this integration there is only one technique. And what is that? Integration by parts. There is no technique, there is simple one technique, integration by parts. So what is this? Integration by part is a special method of integration, right? And that is often used when two functions are in multiplication. So what is trying to say that if I have two functions, okay, function u, this is my first function, okay, so I'll write it here, that what is this? This is my function 1. This is my first function and this is my function number 2. So if I have two functions u and v and they both are in multiplication, okay, if they both are in multiplication, then I will use this by parts rule. Okay, and what is this by parts rule says? That first of all you write u as it is and you integrate v minus you differentiate the first function, correct? Then you integrate the second function and you integrate this function as a whole. Okay, so this might be confusing, this might be a little bit confusing, but when we will solve this question, you will understand it very nicely. Okay, so now second most important thing, how do I choose that whom to keep u and whom to keep v? Okay, so there is a rule, and what is that rule? That rule is ILATE, ILATE. Okay, this rule tells us, right, helps us decide which function to take as u and which function to take as v, right? So now what is this, right? So I is basically inverse function. Okay, if we have an inverse function, this is I, this is log function, right? This is algebraic function, right? What is log function? Something which has ln, log. Okay, if something is written like this, that is log function, right? What is algebra? Normal polynomial, right? Let's say if something x square is written, 2x plus 3 is written, okay, or let's say x cubed by 4 is written, something like this. Okay, then what is this? this is trigonometric function. We all know what is sine, cos, tan, right? You might not know what are inverse function, but later on you'll see there are functions like sine inverse x, okay, cos inverse, something like this, okay, inverse functions. Okay, we will not touch this inverse function right now, but later on in maths you will do that. And finally we have exponential functions. Okay, so what I'll do, okay, let's understand this by an example. Okay, you remember this rule? You just remember this rule, I late. Okay, so let's solve this question. So what is integration x into cos x dx? So what do I have? I have two functions. And what are the two functions? Right? The function one, okay, x, and the other function is cos x. I have two functions, x and cos x. Now how to decide which is what function? Okay, which to take as u and which to take as v, because it is very important, okay, to decide, because if you decide the opposite of that, okay, you will get wrong answer. Okay, you will not be able to solve it very easily. So let's decide. I L A T E, right? I have written here. So now let's see, where does x fall? What is x? X is an algebraic function. So I'll say x will be somewhere here, right? Now second is which function? Second is cos function. So what is cos? Cos is a trigonometric function, right? So I'll say cos is a trigonometric function and it lies here. Okay, so now I have written it here. Now how to decide which is u? The first one is always u, the first one is always u, and the second one is v. How to decide? The first function is u, the second function is v. Okay, I have written it here. A helpful rule of thumb is isolate. Okay, choose u based on whichever comes first. Okay, whichever function comes first, okay, is my u function, and the later function is known as v function. Okay, so now first thing I have done, I am able to decide which is u and which is v. So here which is u? My x is u, right, and this is v. Okay, so now let's write the formula once, so that you get an understanding of what we have to do. So what is the formula? The formula says that u integration v dx minus, okay, right, you have written u as it is and I have integrated the v function, minus you do what? You differentiate the first function. So you differentiate the u function. I have differentiated the u function into, I have again integrated the v function. What did I do? I differentiated the u function, I integrated the v function, and this whole multiplication part is again integrated, This is the whole formula. Okay, so let's do step by step. So first of all, I'll write this u function as it is, I'll write x as it is. Second, integration v dx. So integration v, what is v? V is cos x dx. I have written this, minus. Now I have to differentiate the u function. What is my u function? X. So I'll write differentiation of x with respect to x into, again what do I have? I have to integrate the v function. So what is the v function? V is cos x dx. Okay, and finally what do I have to do? I have to integrate this whole function, right? So I have to integrate this whole multiplication part. So I have to integrate this. Okay, so what have I done till now, right? I have written this formula, u v dx is equal to u integration v dx, right, minus, what is this u dash? U dash is basically the derivative of the function u. Okay, u dash is, this is the u dash part, right? You can also write it as u dash. So this is the derivative of the function u, right, into integration v dx, and again I have integrated the whole function here. Okay, so what I have done, I have written the function, I have substituted the values. We have not solved anything here. Okay, we have not done integration till now. So now I will do integration. Look very easy, nicely. Okay, so x, now x is written as x, simple. Now what is integration cos x? So this is cos x, right? So integration of cos x, if you remember, is sin x. So is sin x, correct? So this part is done. Minus, I'll write this as it is. Okay, now what is this differentiation of x with respect to x? So if you know, differentiation of x with respect to x is 1. So I'll write this 1 into, now What do I have? What is this? This is cos x dx. What is differentiation of cos x? Sorry, integration of cos x. Integration of cos x is sin x, right? Sin x. Okay, remember, see, I have done differentiation because this tells me to differentiate this function. So I have differentiated it here. Okay, but this function later on, it is telling me to integrate. So I have integrated here. Okay, don't get confused here. Into, right? Finally, what do I have to do? I have to integrate this whole function dx. Correct? Now, what do I have? I can write this sin x as it is. So I'll write x sin x minus. Now, what is this? 1 into sin x is sin x, and basically this is integration sin x. And what is integration sin x? Integration sin x is minus cos x, right? It will become minus cos x, right? Plus some constant c, plus some constant c. So what is the final answer? The final answer will be equal to x sin x plus cos x plus some constant c. Okay, so this is my final answer for this integration. I hope you understand this. Okay, I'll repeat again what did I do, right? I have this function x and I have this function cos x, right? I have two functions. So first of all, I will decide that which function is u and which function is v. Why? Because I have to apply which by parts integration. Because if two functions are in multiplication, I have to apply the by parts rule, right? So first, what is the rule? Isolate rule, right? One function is x, other function is cos x. So x is an algebraic function and cos x is a trigonometric function. So the function which comes first is u, the function which comes later is v. So I have written u and v respective. Yeah. Now I have written the formula for integration by parts. Okay, this formula you should know. Okay, this formula you should know, because if you don't know this formula, then you will not be able to do these steps. So what is the formula? U integration v dx minus, how to remember? U integration v dx minus, first I will differentiate this function into integration of v and whole integration here. So let's write u is what? U is x and integration v is what? Cos x dx minus differentiation of x, that is differentiation of u, minus integration of v, that is cos x, and just solve it. So x is x, cos x is how much? Sin x, minus differentiation of x is 1 into differentiation of cos x is sin x. 1 into sin x will give me sin x, and integration of sin x is minus cos x. This is how you get the final answer. Okay, clear? Let's do one thing. Let's solve one more question. Okay, let's try to solve one more question. So now, first again, what do we have? We have two functions in multiplication, right? So I have function number 1 and function 2, right? Let's decide which is one, which is u, which is v. I-L-A-T-E, right? So what is e power x? E power x is an exponential function. So e power x will be somewhere here, correct? My second function is x. My second function is x. And what is x? X is an algebraic function, right? So I know that this will be my u and this will be my v. Okay, so now I am able to decide which is u, right, and which is v. Okay, so now what is the formula? Formula is u integration v dx minus differentiation of u, right, into integration of v, okay, and this whole function, right, is integrated. This whole function is integrated. So let's substitute the values. Simple. Let's substitute the values. So I'll have x integration e power x dx minus, right, what do I have? Dx by dx integration e power x dx, right, into dx. So x into, what is e power x dx? Integration is e power x minus. Now what is differentiation of x with respect to x? Differentiation of x with respect to x is 1 into, now what is integration e power x dx? Is e power x, and I have to integrate this as whole, correct? So what do I get here? Right, what do I get here? I will get x into e power x minus integration of e power x dx, and this will give me x into e power x minus integration of e power x will be equal to integration of e power x, right? That will be e power x. So what do I have? I'll take e power x common, I have x minus 1. So this is my final answer which I will get. Okay, clear? This is the final answer which I have once I integrate this function. Okay, this is the final answer. So if you have any doubts, you can ask. Okay, I will move on to next part. Okay, I will repeat this once more, that what I have done. I want to integrate two functions, e power x into x dx. This is my question, right? What do I have? I have two functions which are in multiplication. So if two functions there are in multiplication, what do? You will use the by parts rule, right? So what is the formula for by parts rule? U integration v dx minus differentiation of u into integration v whole integration, right? And how you decide v and u? By the ILATE rule. So ILATE now. So what is the first function? First function is x, and what is x? X is an algebraic function, A for algebra, right? What is e power x? E power x is an exponential function. So exponential is e, right? E for exponential. So I'll write the formulas, and the function which comes first is u and the function which comes later is v. So I have written u and v here. I have written u and v, and I have substituted the values in the formulas and solved it. Clear? So this is the major steps you have to follow to do the integration. Okay, now let's do integration using substitution rule. Okay, so now we will move forward to do the integration using substitution rule. So as the name suggests, okay, there's the name suggests, what is given here, that what do I have to do? I have to substitute the value. Now what value do I have to substitute? Okay, so here there is no trick. Okay, here there is no it is kind of a logical thing. Okay, you have to think. There is no formula for this type of questions. Okay, you have to understand that what you will substitute, right? What you should substitute with what value, so that you can solve it very easily. So let's look at this question. Okay, and if you think a bit, right? If you think a bit, right? What can I do? So I have this in the denominator, x square plus 1. Okay, so what I'll do, I'll try to say, let's say x square plus 1 is equal to t. Okay, I'm letting this. Okay, so once I find this, what I'll do, I'll differentiate both the sides. Okay, next step is differentiating both the sides. So when I differentiate this with respect to x, right, what do I get? Dt by dx. Differentiation of t with respect to x, what I'll get? 2x plus 0. Correct? So what do I get? 2x is equal to dt by dx, and from here I can say dx is how much? Dx is dt by 2x. Okay, I have this. So now let's try to solve this. Okay, so now I will substitute our integration. I'll write this x as it is upon, what is x square plus 1? X square plus 1 is t into, what is dx? Dx is dt by 2x. Dx is dt by 2x. Correct? So this x cancels with this x, and finally what do I have? I have 1 upon t dt. So if you look here, what has happened, that my variables which were x, no, this was in x, right? X was the input variable, and I have to differentiate with respect to x. But now when I solve this, what do I have? 1 by t dt. Okay, and this is very simple, no? This is very simple. So now what is the formula? What is the answer for this? The answer for this is ln t. ln t. Correct? And I will finally substitute the values of t again in the equation. So what do I get? ln, right? And what is t? T is x square plus 1. X square plus 1. So this is my final answer. This is my final answer. So what has happened here basically? With some smart substitution, right, I am effectively able to solve this question. Okay, I am effectively able to solve this question. Okay, so this is what we have understood from this question. Okay, and how to, okay, the more you solve these type of question, the more you practice, the more you will be able to, right? Look at these questions, okay, that okay, this question can be solved like this. This is a hit and trial method where you try to assume something, and if that works, you will be able to solve the question very easily. Let's see this question, okay. So integration of, right, I have sine 2x dx. So I know what is integration sine x dx. What is integration sine x dx? Integration sine x dx is minus cos x. But what about integration sine 2x? Right, I have this 2x factor. So let's do one thing, let's make this 2x as something, okay, let's substitute. So I'll say that 2x is equal to t, let's say, and I'll differentiate this with respect to t. So dt by dx will give me 2, right? So what can I say? I will say that dx is equal to dt by 2. So now let's substitute the values here. So once I substitute the value, right, I will have sine into 2x. So what is 2x is t, and what is dx? Dx is dt by 2. Dx is dt by 2. So now what do I have? What can I write this as? I can write this as c. Now what is this 2? 2 is a constant, so I can take this 2 out of the integration. So I will have 1 by 2 integration sine t dt. Integration sine t dt. And what is integration sine t dt? Integration sine t dt is minus cos t, right? Minus cos t. So I can write this as minus cos t. Correct? And finally, what do I have to do? I will again substitute the value of t, because my original question was in terms of x. So I will again substitute the values of x here, right? So I will have 1 by 2, right? This minus sign. And what is t? T is 2x, right? So I can say cos 2x. Okay, so this is my final answer. Clear? This is my final answer. So from this, right, from this we can basically write some new formulas, okay. And what are the new formulas? These new formulas are also very useful. And what are the two formulas? That if I have something like this, okay, if I have a question like this, sine ax dx, integration sine ax dx, right? So what can I say? What is integration sine x? Integration sine x is minus cos ax divided by a, okay. You will divide it by the coefficient of x. Similarly, let's suppose if you have cos ax dx, right, that can be written as sine ax by a. This will become sine ax by. Okay, let's suppose if you have something like this, right? Okay, so let's suppose if you have something like this, okay. Okay, these are the major formulas you should understand. Okay, let's suppose let's do one question. Okay, if I have a question something like this, that integration of sine 2x plus 3 dx. What is the integration of sine 2x plus 3? Okay, so now what can you do? Okay, you can directly write this as, see, you can directly integration of sine x is cos x 2x plus 3, right? And what did I tell you? I told you to divide by the coefficient of a, right? X. So what is x? Is 2, right? So I will divide by 2. Okay, and we can prove this. How we can prove this? Same by substitution method. Okay, right? Substitution method. This proof is very easy, right? What do? I will substitute 2x plus 3 as equal to t, right? I will say 2 into just 1 minute. So once I differentiate with respect to x, this will become dt by dx will be equal to 2 plus 0, right? So I can substitute the value what? I can substitute from here that dx is dt by 2. So once I integrate, what can I get? I will get sine, right? I will get sine. Now, right, what is t? T is 2x plus 3 is t into what is dx? Dx is dt by 2, dt by 2. So what is integration sine t is minus cos t by 2. And I will substitute the value of t again. So I will get minus cos into what is t? T is 2x plus 3, 2x plus 3 divided by 2. Okay, so this is the way you can remember this formula directly. See, you don't have to do this again and again. Okay, the formula is very simple. If I have sine ax into dx, this will become cos ax by a. Okay, clear? This is very important. Please remember this also. Okay, these are formulas. Okay, you go up. Okay, do some homework. Go up on the internet. Okay, and type integration formulas. The simple integration formulas, differentiation formulas. You will get a list of all the formulas. Okay, and there you do one thing. You take those formulas. Okay, and you put those formulas on your wall. Stick those formulas on your wall. Okay, and you every day remember them. You every day when you wake up, okay, or whenever you get time, you go and look up to the formulas and you read them once. I'm not telling you to go and sit there for hours. Okay, for 1 minute you look at them and you try to read them. Okay, eventually what will happen, that these formulas will be stuck in your mind forever. Okay, and okay, what will happen, eventually you will become very good at these. Okay, if you become very good at this, right, the fear of maths will go away from you. It will vanish. And this is how you become very good at physics, because physics is basically maths only. Okay, physics are concepts, but how do you present the concepts? The concepts are presented by maths, right? So that is why I always focus, or I tell you that, okay, maths is very important. And in this basic maths course, or the mathematical tools part of this physics transition course, right, what we are doing, we are always targeting the maths part. I have not started with physics. I have not taught a single concept of physics in this physics transition course. Why? Because the most important thing is maths here. Once you are able to grasp these topics, whatever topics which we are doing, okay, we started with functions, then we did trigonometry, then straight line, quadratic equations, right, then we did differentiation, right, and now we are doing integration, and the last part will be vectors, which will be starting in the next class. Clear? So if you, right, basically I am telling you that give some time to these. Okay, it will not come automatically, and it is not that easy also, right? Initially it is very difficult to grasp, but as you practice questions, right, you will say that, okay, this is very easy. Okay, so let's continue. So this is a homework question I will give you. Okay, please try to solve this question, and we will discuss this in the next class when we meet. Okay, so now we have definite and indefinite integration. Okay, so what is left now? So in integration, only application parts of integration is left. Okay, and what is the application? Right, so the application of integration is basically finding area under a curve. Okay, and this we will start in the next class. Okay, so if you please, okay, so do one thing now. For now, I have given you question, and if you have any doubts, okay, if you have any doubts of whatever I have taught you, okay, and if you want to like ask any questions, right, Rajat, if you want to ask any questions, okay, you do one thing, you scan this QR code. Okay, and there a Google form will be there, right? You try to, in that Google form, okay, you ask all your questions, all your doubts, okay, and I will answer them. Whatever doubts you have, academic, non-academic, right, no matter what, you please ask. You scan this Google form, right, and it will help you and me to communicate. And also I will be sharing, right, notes and the formula sheets with you on this Telegram channel. So please scan this QR code for this Telegram channel and join our Sri Chaitanya Academy Telegram channel. Okay, so I hope this session was helpful for you. Okay, and we'll meet again in the next class, and we'll continue this with this integration and vectors. Okay, so thank you everyone. Have a nice day.